Now let us take a look on the problem number 1 on the tutorial about Mohr circles. Now this is the stress element given. Now the stress state is that there are two planes, right? Horizontal planes B and vertical plane A. Now on the plane A there's a direct stress 100 megapascal, and on plane B the direct stress is 60 MPa, and there will be two pairs of shear stress 48 MPa. Now we are going to find the principal stresses sigma max and sigma minimum. So you have to plot the shear stress against the direct stress graph. Okay, first of all, for the plane A you have two data, right? 100 MPa and 48 MPa. So that is 100, right? 100 here, 100 here, and that is the 48 because that is the shear stress. So that's the point for the plane A. And plane B, similarly, right? You have the direct stress 60 and 48. So the direct stress 60, so 60, and 48. So that is 48. That's 48. Now that's 100. That's 60, right? So you got the 2 points here, right? Point A and point B. So you better draw that, join that. Then you got the center here. So what's the location of the center? So 100 per 60, because it's midway in between. So 100 per 60 divided by 2, so that's 80. And that's the zero stress here. So the center is 80 and 0. Now you draw the Mohr circle. So and then you have the other half. Okay, that's the Mohr circle, right? Because you got the center and that's the radius. That's the radius. Now we are going to pick up this triangle, right? Now can you find the radius? Because what's the value of here? That's 48, right? So that's 48, right? And what's the base here? 100 and 80, so that would be 100 minus 80, 20, right? So what's the R? So R is equal to what? Pythagoras theorem, 40x squared plus 20 squared, right? So it will give you 52 MPa. Okay. Now what about the theta here? Now that's 2 theta, right? Because in Mohr circle we always have that 2 theta. So theta equal arctangent, right? 48 divided by 20, so it gives you 2 theta, and that will give you what? Theta equals 33.7 degrees. Now please note that it's rotated in counterclockwise direction. Now, so you got theta. So what's the sigma maximum? Very easy, right? that is sigma maximum, and that is sigma minimum. So what's sigma maximum? So you can say here the 80, right, plus r, 80 plus radius. So it gives you 132 MPa, right? What's sigma max? Sigma minimum? Well, it's equal to what? 80 minus r. So 80 minus 52. So it gives you 28 MPa. Now, so that's the answer, right? Now, what about the second part? You are requested to work out the stress on the element, right? By rotating the plane, right? Or rotating the element in anti-clockwise direction by 30 degrees. So what you're going to do, so that's the plane A. So that is for the plane A. So you rotate it by not 30, right? 2 times 30. So 60 degrees. In other words, you are going to want to know what's this stress state for the A dash and the B dash. So for this, so you have considered this triangle. Now, for this triangle, you want to know, let's take the triangle over here, right? So that's the radius, right? 52, and that's 60 degrees. So you can work out that is what? Cosine 60 times 32, and that's 52 sine 60, right? So what's the value here? So it's 80, right? 80 minus this one. So the sigma A dash equals to 80 minus, right, 52 cosine 60, right? Oh, sorry, you have to know that it's not 60, right? That's alpha. What's alpha? Alpha equals to what? Alpha equals to, 180 minus this angle and minus 60, right? So 180 minus what? That's 2 theta, right? 2 theta. So minus 2 theta minus 60, right? So it's equal to 180 minus 2 times 33.7 degree minus 60, right? So you got what? 52.6 degrees. So that's wrong. Cosine alpha, right? Alpha 52.6 degrees. So it gives you what? 48.4 MPa. And what about the sigma B dash? So what's the stress here, right? So it's equal to what? That is 80 plus what? 80 plus 52 cosine 52.6 degree. So it gives you 41.3 MPa. Sorry, it should give you 111.6 MPa. And what about the shear stress? Is equals to what? 52, right? That is the shear stress here, right? So it's equals to 52 times sine 60. Give you 41.3 MPa. So that's the answer, right? Now, if you can draw that's the original element. Now, after you rotate it by counterclockwise, right? 30 degrees. So you got the stress element. So that's plan A. So you come to A dash here. So that is the 40.4. And then you have the B. That's the B, right? 111.6. 111.6, and you got the shear stress, right? .3. Okay, that's the solution.